All right, class, welcome back. This is 9.3, more on exponential functions. This time we're going to talk about equations and how to solve these exponential equations. We're going to use this rule here that says, remember that the base, whatever our base is, it has to be greater than 0, so it has to be positive, and it can't be 1. Otherwise, these rules don't apply. Okay, so we can't have a base of 1 here, and again, we have to have positive numbers. If those rules apply, okay, then if I have the same base, then their exponents equal each other. That's what this means. If I can make them have the same base, then I can drop the base and set the exponents equal to each other. So the way that we're going to solve these is we're going to put them into their base. Factor them out. So the number 2 or the number 4 could be written as 2 squared. But that squared is going to be times the exponent that is already there. Okay, but again, I'm just rewriting this number 4 with a base of 2, because if I can make the bases the same, then I can get the exponents to equal each other. And I'm going to rewrite 8 with a base of 2, but 8 is 2 cubed, but that would be times the x that's already there according to the rules of exponents. Okay, now that I have the bases the same, okay, the base is 2, then I can just set the exponents equal to one another. So I will get, I'll distribute here and we'll get that 2x plus 6 is equal to 3x. I'm going to subtract the 2x and we get that x is equal to 6. Pretty crazy that we can just solve it that way, but if we can make the bases the same, then we can solve for the exponents. I can pretty much guarantee you'll see this on the final, so I would make sure that you know how to do this. Again, we're going to practice 3 more here, but we're going to take those bases and bring them all the way down to their most factored form and try to make the bases the same. And then once they are, then we set these exponents equal to one another and solve. Okay, so 125 is the same thing as 5 cubed, but it's going to be multiplied by this x. Probably a more accurate way to write this would be to say that 125 is the same thing as 5 cubed, and this is being raised to the x still. That way you can see the rules of exponents. Remember that the power rule of exponents says that if you have a base raised to an exponent, and that is raised to an exponent, then the relationship of these exponents is multiplication. So that is why I'm multiplying these exponents. Okay, if we write 5, we would write 5 squared. So 25 is the same thing as 5 squared. We're raising that to the x minus 2. Again, this 2 belongs or will be multiplied by both of these. So this would be equal to 5 to the 2x minus 4. And when I have the bases the same, then I can cut the bases out and just say, hey, these exponents equal one another. So 3x is equal to 2x minus 4. Subtract the 2x, and here we get that x is equal to a negative 4. Okay, maybe pause the video for just a minute and see if you can work these two. Come back on and compare your work. All right, so here we want to say what is the base, or what is our common base here? We can get down to a base of 3. So this is the same thing as 3 cubed here. And this is the same thing as 3 to the 4th. 81 is the same thing as 3 to the 4th. 3 times 3 times 3 times 3 is 81. So I'm just rewriting it in exponent form. Again, the relationship of these exponents is multiplication, so I am going to distribute here. So we will get that 6x minus 15 is going to be equal to 4x plus 8. Again, when the bases are the same, I can just drop the bases and compare these exponents. So I'm going to subtract the 4x from this side and add the 15. So we end up getting that 2x is equal to a 23 divided by 2, and our solution here is x is equal to 23 halves. All right. So, like I said, kind of crazy that you can just boom, drop those bases, but you can, and that is the rule that we're using here. We're using the rule that if the bases are equal to each other, then their exponents are equal to each other, and the power rule. 32 is the same thing as 2 to the 5th, and that's going to be equal to 2 to the 7x minus 3. Well, I'm just going to drop these bases and say that 5 then is equal to 7x minus 3. I will add the 3. I was doing it already in my head. 8 is equal to a 7x. Divide by a 7, and we get that x is 8/7. Of course, once you get to the point where you are just dropping the bases, these equations, you know, at this point here, 2x plus 6 is equal to 3x, they're easy to solve from here, so we already know what to do there. So this is solving exponential equations.